the interaction between that classes and or that objects. Okay, it distribute the responsibility between that objects. Okay, so these are the three types of patterns here: creational patterns, structural patterns, and behavioral patterns. So these are the GOF patterns here, you can see. So creational patterns is there, structural patterns, and behavioral patterns. Here you can see the creational patterns include abstract factory, then builder, factory method, prototype, and singleton pattern. These are under creational patterns. Okay, then next one is structural patterns. The structural patterns include adapt pattern, then bridge, composite, decorator, then facade, flyweight, proxy, then behavioral patterns. It includes the chain of responsibility, then command, then interpreter, iterator pattern, mediator, then memento pattern, then observer pattern, state, strategy, template method, and visitor. So these are the 23 patterns from their GOF. GOF patterns include this 23 pattern under three category, that is creational patterns, structural pattern, and behavioral patterns. Okay, these are all patterns we are going to see in upcoming slides or in upcoming lectures. Okay, so we are going to describe the design patterns. What are the notations? How that patterns are going to be described? Okay, so graphical notations. While these are important and useful, okay, these graphical notations and important and their useness are not sufficient for that describing that design patterns. Okay, so they capture the end product of the design process as relationship between classes and objects. Okay, they capture the end product of the design process. Okay, it considers that relationship between the classes and objects at the end of that product. By using a consistent format, we describe the design patterns. There are some formats for designing that software or design or using that design pattern, so that we can describe that pattern for that system or for the design. Okay, so each pattern is divided into number of sections according to some templates. Okay, we are going to divide the pattern is divided into number of sections. Okay, so describing design patterns include pattern having name and classification. Okay, pattern having name and classification having intent. So what pattern name and classification includes, it conveys the essence of pattern. That pattern is having good name. Okay, so that we can, it will be a part of design vocabulary. Okay, so that pattern is having the good name for that design pattern, so that we can classify the patterns based on their names, based on their suitability, or based on their design. Okay, then intent of that pattern, what that pattern or what does the design pattern do, that is the intent of that pattern, what that pattern is going to be do for that design. Okay, what is its rational intent. Okay, rational and intent of that pattern. Then what particular design issues or problem does it address, what that pattern is going to be addressed for that design, what are the design issues for that software design. Okay, this is the intent of that pattern. The pattern is going to be described by their name, their classification, and intent. It's also known as other well-known names for the patterns. Then the motivation of that pattern. What that motivation? A scenario that illustrates a design problem and how the class and object structures in the pattern solve the problems. Okay, what is the motivation behind to solve that problem of that or the design problem, that which software design or which software design pattern should be used for that design problem. That scenario will help to understand the more abstract description of the patterns that we are going to follow. Okay, so which patterns we are going to follow for that particular design. Okay, that will help for the or for going to be or that pattern is going to be the abstract description for that solution. Okay, so that it also includes the applicability. Okay, So applicability means what are the situation in which the design pattern can be applied. That is applicability. In which situation or in which conditions we are going to apply that particular pattern to that particular software design problem. Okay. So then what are the examples of the poor design that are that the pattern can address? Okay, based on that we are going to select the design pattern. How can recognize the situations? Based on the situations we are going to select the design patterns. Okay. Then the structure, that graphical representation of the classes in the pattern using a notation based on object modeling technique. We are going to structure or we are going to represent or the graphical representation of the classes in the design patterns. It uses the notations from object modeling techniques. There are different notations in object modeling techniques. Okay, that is OMT. So there are some participants in that design patterns. Okay, participants may be classes and objects. Okay, and their relation or their responsibilities. These are the participants in design patterns. Okay, then the collaborations for design patterns. What that collaboration is, that how the participants collaborate to carry out their responsibilities. How that participants, we have seen that classes, objects and their responsibilities. These are the participants of the design patterns. How they are going to collaborate with each other with their responsibility to carry out their responsibilities. Okay, then consequences. Consequences like how does the pattern support its objectives? These are the consequences. What are the trade-offs and results of using the patterns? What are the trade-offs and what are the results we are going to use of we are going to get after using the particular pattern? Then what aspect of the system structure does it let vary independently? Then that structure will be changed after using any particular pattern with that software design. Then implementation consists of what pitfalls, hints, techniques should be aware of when implementing the patterns. Okay, so which patterns will be selected based on their criteria or based on their applications. Okay, are there language specific issues? Is there any language specific issues will be there while implementing that pattern? Then the describing design patterns includes some sample code. That sample code fragments that illustrate how might implement the pattern in C++ or Smalltalk. We can convert that design patterns into sample code. There are some uses like example of the pattern found in real systems. Okay, some related patterns are also there. That includes, these are the description of the design patterns, what that pattern consists of. Okay, so related patterns are there. What design patterns are closely related to this one? Suppose we are going to use the abstract factory method. So what that abstract factory will include, or what are the design patterns that are related or closely related to that pattern? Okay, so what are the important differences between that patterns? Why we are going to use that pattern? Okay, with which other pattern should this one can be used? In which, so what is the suitable pattern for uh, that pattern we are going to use? Okay, so these are all about that how that pattern is going to be described here. Okay, so what that pattern, what that design pattern consists of. Okay, the next point is relationship between patterns. So there are some relationship between number of patterns, that patterns we are going to use for software design. Okay, so some patterns are used together. That we have seen the different patterns. 23 patterns are there under three category. So that patterns are used together. Here you can see the, for example, the composite pattern is sometimes used with iterator or visitor pattern. Okay, so that pattern, number of patterns can be used together for getting the solution for that problem. Okay, so some patterns are also defined as alternatives for others. Alternative patterns. Okay, so we can use number of patterns instead of that selective patterns. Here you can see the example, the prototype pattern can be used as an alternative to the abstract factory pattern. Okay, so instead of using abstract factory pattern we can use the prototype pattern also. Okay, these are the relationship between that number of patterns. Okay, we can use alternative patterns for number of patterns. Then some patterns like the composite and decorator pattern result in similar design. The design of that composite and decorator pattern will be the same design they are having. So we can use that either composite or decorator pattern. Okay, so these are the relationship between patterns. That number of patterns are having similar designs. Their work, their we can use the patterns instead of, or we can use the alternative patterns. Okay, like instead of prototype pattern we can use abstract factory pattern. Okay, we can use the number of patterns together to achieve the certain results. Okay, then creational design patterns. Okay, we have seen three categories: creational, structural, and behavioral patterns. Okay, so first one is creational design patterns. That includes abstract factory. Okay, what that abstract factory? It is a factory for building related objects. Building related objects. This is the short information or single line information about that all the factory, sorry, all the design patterns under the creational patterns. Okay, so in afterwards we are going to describe, or we are going to see the all these creational, structural, and behavioral patterns in deep. That is your chapter number